right, guys, this is section 1.3. The learning targets for today are a little wishy-washy because there's some things we're going to talk about today that you do not have to know for a test or a quiz. They're just information leading to what you're going to have to know in calculus, okay? The one thing you do have to know today is about end behavior, which you did last year, okay? Does the left side going up, down, what's it doing? So we're going to talk more about that. We're going to talk about limits today, but I am not going to ask you any questions about limits until second semester when we will revisit that. Continuity, you kind of have to know. This is the deal. They're going to talk about different kinds of continuity today. I just want to know, is this graph continuous at this point, yes or no? I'm not going to ask you what kind it is. All right, so that'll make a little bit more sense in a second here. The definition from our book says a function is continuous at a certain value if the function is defined at that value. In other words, if we're looking at x equals 2, if we can put a 2 in and it's defined, it is part of the domain, okay? And if the value of y approaches the same value from the left and right of that value we plugged in, like 2. Let me give you an example. If I had this graph and I wanted to know, is this function continuous at 2? You would say, well, it obviously has a point at 2, yes? And it is getting closer to that same point from both directions, so it's continuous. All right, so we're used to things being continuous. Discontinuous would be if we had a graph that looked like this. This graph at 2 is not continuous. It jumps somewhere else, okay? While there is a definition at 2, it is not approaching the same value from the left and the right as we get closer to 2. Another discontinuous graph would be something like this. Does this look familiar, guys? Got an asymptote, okay? That's discontinuous. All right, I want to go back and review a little bit of vocabulary or a little information from reading a graph. You don't have this, so this is just a warm-up. What is this asking? Use the graph to estimate the indicated function value. This is saying when x is -2, what's the y value? So when x is -2, what's the y value? -2. All right, what about b, -6? -6 looks like -8. And those of you further away probably can't tell the difference. It is an open circle. If this is an open circle, is there a value at -6? So b is actually, it's undefined, doesn't have a value. What about c? F of 0. Yeah. This is anywhere here, is it crossing? No. So c is undefined. This is totally different. Do you know what this means, guys? Yes, f of x means y. So if y is 2, what is x? If y is 2, what is x?
6.
I think they're counting by 2, so it would be 6. Everybody okay? Now this is the tricky one. If y is -6, then what? Let me erase some stuff here real fast. If we're looking at where y is -6, what are we going to have? Something here close to -5 and close to 8-ish over there. Yeah, it's just an estimate from the graph. But everybody understand there could be 2 values for the y. Can't be 2 values for the x. Does it have the same y? Because then it wouldn't be a function. All right. We also did this yesterday. Even, odd, or neither. Do you remember the definitions of those? What did even mean?
It was symmetrical over the y-axis.
Yes, y-axis. Odd. Symmetry with origin. Why wasn't there one for x-axis? If you can fold it this way, it's not a function, right? Because it's got fails the vertical line test. All right. With that being said, we learned a cheat. Do you remember the cheat for polynomials? This has a power of 2 and a power of 0. What are you thinking? Even. Okay? Where's an odd? This is an odd function. Where's a neither? 68 is a neither. 66, somebody said?
Maybe not. I was thinking, I saw y, so I immediately thought.
Yeah, they're just using a different variable. What about, is this one even or odd, 66? Yes, because this would be this is even. 62, what do you think? X by itself is an x to the first power, right? So it has even and odd exponent powers, so this one is a neither as well. All right, just a quick review of that. Can you look at this one? Tell me which one you think is an even function. A has evens and odds. We're looking for an even. This is an odd, right? This has evens and odds. Yep. Okay. I did number 110 wrong earlier today. How do we decide on the domain, guys? Set what equal to 0? What do we need to do? How does it factor? I wrote down x squared minus 16, so then I factored x minus 4x plus 4, and so I thought it had critical values at negative 4 and 4. That was totally wrong. It only factors like this, so where are the critical values? X cannot equal 0 or 16, which is which one? Be careful. This would be a hard bracket, would include 0 and 16 and nothing in between, right? The one that includes in between, outside, but not 0 or 16 is F. That kind of question is on the test quiz next Wednesday, okay? There's one question about domain where you just make sure the denominator does not equal 0. Okay. Back to the new stuff. Continuity. The graph of a continuous function has, this is pretty easy language, guys, no breaks, holes, or gaps. You can trace the graph of a continuous function without lifting your pencil. Okay? Does that make sense? Seem okay? The concept of a limit, okay, the concept of approaching a value without necessarily ever reaching it is called a limit. We will spend a lot of time on limits at the very end of this course because it's the first thing you do in calculus. All right, functions that are not continuous are called discontinuous. Okay, I'm going to take a deep breath and read this sentence because it has a lot of syllables. Graphs that are discontinuous can exhibit infinite discontinuity, jump discontinuity, or removable discontinuity, also known as a point of discontinuity. Breath. Okay. We will talk about these, but you will not be asked on an assessment to differentiate between the three until calculus class, okay? Infinite discontinuity is when there's like a vertical asymptote. Does that make sense? That the graph is not continuous? I can't trace this without lifting my pencil, right? Because there's two pieces. A jump discontinuity, does that kind of make sense? When it gets close to C, it jumps up here. And a removable discontinuity, this is the one you should be familiar with from last year. It's when a graph has simply a hole. For example, this line I'm going to say looks like the line y equals x plus 3. What do you think? Does that look like it could be the line y equals x plus 3? Okay. What would make this have a discontinuity is if we added this to it, like x minus 1 over an x minus 1. That means this is undefined at 1, but in essence, after we found that whole, we could cancel these and say it's just the line x plus 3. Okay? But because this was actually part of the original definition of y, or f of x, it would have a hole there. Does that sound vaguely familiar? Okay. When you get to calculus, there's a way for this particular one, it will still have a limit near there. Okay, you can take care of that. I don't know if there's a slide about that. Okay, yes, infinite and jump discontinuities are classified as non-removable. Okay, but later on it says that you can do something to remove the point of discontinuity and still find the limit. All right, back to the things you should be able to do. I'm going to talk about the 3 ways to prove that something is continuous, and then I'm going to tell you that most of the time you're not going to need to do them, okay? But I want to talk through them. This says f of x equals 2x plus 3 is the function we're talking about, and it wants to know, is it continuous at x equals 2? The first test is plug it in and see if it works. Okay? If you put a 2 in, what do you get out, guys? 2 times the absolute value of 2 plus 3. You get out a 7. The second thing it says is test if it's approaching the same value from the left and from the right. Close to 2. Okay, we're trying to test at 2, so you would test these kind of numbers. Do you see where that's close to 2? Getting closer and closer as we go down? These are close to 2, getting closer and closer from above 2, right? These are slightly greater than 2, these are slightly less than 2. And you will notice that it is approaching the same value, getting close to 7. Thanks. All right, that would mean that it is continuous and the limit at 2 is approaching 7. What about this one, guys? It asks for the limit, or I'm sorry, is it continuous at 1? It's kind of small, but it says 2x over x squared minus 1. Any ideas? The 1 would make the denominator 0. So do you think it's continuous there? No. Okay. This function, it is discontinuous or not continuous. Just says determine if it's continuous. Okay. I'm not going to worry about what kind it is. This is the test that would actually show that it's it has an infinite discontinuity. They put in numbers close to 1. Does everybody see that those numbers are close to 1? Just below, and these are just above. Well, on one side it was getting very negative, on the other it was getting very positive. It means the graph was doing this, right? Had one side going down, one side going up. Something like this, okay? All right, this is question, if you have a person who looks back at your notes before the test, make sure you look at a question like this. There is one like this on the quiz next week. I'm going to talk about it, and then I'm going to go back to tell you what kind of question it actually is on the quiz. 2x plus 1, guys, what is that graph as? A line. Continuous, yes? X minus 1. Line. It's continuous. But this has some extra information. It's a piecewise function, and it wants to know, is it continuous at 2? In other words, do the 2 pieces meet up at the same place at 2? Is 2 a critical value in this function? It changes from one rule to the other, right, at 2? So we need to determine what happens. If I put a 2 in, I put it in which one? The second one. So I do 2 minus 1, and I get, so when I put in a 2, I actually get out the point 1. But what if I put in something slightly less than that? Like 1.9. Which rule would I be using then? Less than would still be this one, yes? Less than 2 would still be this one. So if I subtract 1, I get 0.9. Is that still close to 1? And if I had put 1.999 and subtracted 1, I'd have 0.999. It's very close to 1. What else do I need to test? Just above 2, like 2.01 or something? Which rule would I put that in? The first one. So I multiply it by 2, I'd get 4.02. Add 1, I get, 5.02. Are they meeting up? Doesn't seem like it. The other thing you could do is put 2 into both of these, because this one just has an open circle at 2. You understand that? The greater than means an open circle. 2 times 2 plus 1 is 5. So 2, 5 has an open circle. And here if I put a 2 into this one, I get 2, 1 would be a solid circle. Solid. Okay, obviously not the same point. Just because eventually you're going to have to do these, I'm going to run through what the graph looks like. Badly drawn, no doubt. 2x plus 1 would cross at 1, and it would be going up kind of steep, okay? What does x minus 1 look like, guys? Crosses here, and it's less steep, right? But still going up. How do I figure out what this graph actually looks like? Do you remember you have to do some erasing? Okay, if this is x equals 2 over here somewhere, which side am I erasing of the top line here? The top rule was this 2x plus 1 is this top line, and I want to keep the piece to the left or right? To the right. I would erase this over here. Solid or open circle, what did we decide? Greater than 2 would be an open circle. So this other line, what am I doing with that guy? He works when it's less than or equal to 2. So I get to have a solid dot there and erase the right-hand side. Does some of you remember doing these? Okay. So you have a line going here and a line going here. They do a very good job of erasing. That's not horrible. All right, so definitely discontinuous. That's what you had to decide. Oh, I wanted to tell you what the quiz one would look like. The one on the quiz actually says this graph is discontinuous at, and then it lists 4 points. 0, 1, -1, and 2. And you have to figure out which one it's discontinuous at. Does that make sense? Hint, it's probably a critical value. Okay? Now, if this had more rules, there could be more critical values though, right? More places where the graph changed. All right, we'll practice that closer to the quiz. All I want to know is this continuous. What do you think? Is this continuous at 4? Miranda says it's a parabola. Does that help us? Does it have a value at 4? It's a parabola, right? Does a parabola have places where there's no denominator, right? Domain is all real numbers, so it has a value at 4. It's continuous. If we understand that concept, do we really need to test 3.99, 4.01? I don't think so. Because I'm not going to ask you what kind of discontinuous spot it has. I just want to know, is it continuous or not continuous, okay? All right, we'll come back to that and practice a little bit more in a minute. There's a theorem in your book used a lot in calculus called the intermediate value theorem. The part we're focusing on today is this part down here that says if a function is continuous and you have a value that has a positive sign and a negative sign, opposite signs of each other, then there exists at least one 0 in between those 2 points. Okay, that sounds all huge and complicated. This is old school. When Hofbauer took this class, there were no graphing calculators, okay, guys? So what I had to do for fun with a function like this, it doesn't factor, right? I can't do anything with this, x cubed minus 4x plus 2. I had to, by hand, put in integers. This one says from -4 to 4, so I did. I plugged all those numbers in by hand for a good time back in the day. Then to figure out where the zeros existed, I looked at the y values. See if this makes sense, guys. If the y went from -13 to +2, didn't the graph have to cross the x-axis in between those? So that meant there was a 0 between -3 and -2 somewhere. Is this hugely important to you guys? Not in my opinion. You have a graphing calculator, you can calculate exactly where the 0 is, right? Where else does this one, just humor me for a second, where else does this one have zeros? Here it changes the y value, so between 0 and 1. Between 0 and 1 there was one, and then it changed back, so there's another one here between 1 and 2. Okay? The fact that a graph, that those values change sign, indicates there's at least one 0 in there, but the fact that it doesn't change sign doesn't mean that there couldn't be a 0. That sounds really confusing. This is not hard to understand, guys. Look at this graph. If this was -3 and this was -2, would you notice a sign change in between those? No. If this was +1 and this was +2, and I only tested 1 and 2, the value at 1 and the value at 2, would I notice any sign change? No. So it's possible that there are zeros that you would not find by that method. Welcome to my world back in the day, okay? We're going to use a graphing calculator, and we're going to zoom in if we have to and look closely at things. So I'm not going to make you do this consecutive integer business. All right, end behavior. Everybody awake? This is really important. I think you're already pretty good at this. I hope. All right, which axis runs left and right, guys? That would be the x. Everybody with me? Which axis runs up and down? The y, also known as f of x. Okay. What is the far left value in terms of infinity going to be called? So when we're talking about the left side, we're going to say as x decreases without bound or approaches negative infinity. Does that seem okay? What would the far right be called? Okay. What would the far up be called? Y is approaching positive infinity, and down would be y is approaching. Okay. Some of you struggled with this last year. I know this because I've taught Honors Algebra 2, and some people just don't get, you have to break it down into little pieces and think about it. This is saying as you go to the left, this is saying as you go to the right, up, down, okay? This particular graph shown here, as it goes to the left, it is going up. They would write the limit as x approaches negative infinity of f of x is infinity. It's going up. The y is going up. We're not going to use limit notation yet, but it's really the same as what we're going to write. We're going to write as x approaches negative infinity, f of x approaches infinity. Where's that worksheet for? Okay. All right, so let's talk about what you have on your notes. The vocabulary says as x increases or decreases without bounds, that means you're going x is approaching negative infinity or infinity. This would be left. This would be right. Okay, they would say what is the limit approaching. We're just going to say what is f of x approaching. And if it was a positive, it would be up Because a negative infinity would be down. Does that seem okay? All right, so this vocabulary reads the limit of f of x as x approaches positive infinity, etc. It is. All right, so help me with this. See if you remember. These two go together. What do you want to tell me? Okay, so which, if Miranda picked to go with infinity first for x, which side is she describing? The right side. Okay, and what is the right-hand side of this graph doing? Going up. So that means y is approaching positive infinity as well. So she said, I want to do the right one first, and it's going up. What do we have to pick for this x then? You need to tell me the left end, and this particular graph, the left end is doing what? So we have negative infinity down. Anybody willing to fess up that they struggled with this last year? Is it getting a little bit better now as I go through it, or still confusing? Okay. What can you tell me in words? I don't want you to use any of those words we just did. Just tell me, what do you see going on here? Both ends are going down. So no matter how far to the left I go, it's going to continue to go down. No matter how far to the right I go, it's going to continue to go down. Okay, how are we going to write that? Okay, negative infinity means we're talking about the left, just to clarify. Obviously, it wouldn't matter for this one. F of x is going to approach. Okay. Good job, Sarah. All right. So what you would need, if this was a multiple choice question, because these are, and they look confusing because there's negative infinities and positive infinity everywhere, right? What you have to know is these two, the x's have to be different, right? You have to be talking about left and right end. And these two in this particular question both have to be going down. Okay, so be careful you're reading them closely. All right. Unfortunately, not everything goes either up or down. And we're at a point where we're just doing these graphically. So what I want everybody to do is I want you to type this in your calculator, and we're going to use a method to see what this is approaching on the left and on the right. It is not approaching infinity or negative infinity. It's approaching what we're going to eventually call an end behavior asymptote, what last year you called a horizontal asymptote. Does that sound familiar? Okay. I want you to type this in. What do y equals? What do you need for this question? 5x over x minus 2. You need some parentheses. You don't have to absolutely have them around the top. I would put them top and bottom. If there is any addition or subtraction going on top and bottom, then you need them both. So I'm just going to practice putting them both. Okay? Then I'm just going to do a zoom standard to start with, zoom 6. That's kind of what they did. Theirs is a little bit wider across, but it doesn't really matter. Okay, there's the picture. I can't tell what it's hitting on the left and the right or what it's approaching. I want to teach you to use a feature of your calculator called Ask Auto. Go to second and then table, or second window, sorry. Second window, everybody got it? It does not matter what those first two values are because I want you to set it to Ask and Auto. So arrow down and make the first one Ask and the second one Auto. What that's going to do is it's going to let you put in X values and it's going to find the Y values for you, rather than scrolling up and down the list. Does that make sense? Okay. Go to second graph. Okay, I could delete these. If you have numbers, it's not really even worth your time to delete them. Tell me some numbers that are really far left. On my graph right here, negative 20 would be really far left, right? But what if it continued going to the left forever? Negative 150. What's even further left? Negative 2016. Could you just type negative 99999? Okay. What is this approaching? Can you tell what it's getting close to? Now, if I do negative 99999,
I put a whole bunch of nines and mine says negative 1 e to the 11th is 5.
All because there's too many
Okay.
four nines.
yeah. Look, guys, if I, right now mine says 5, but if I arrow up and over, it actually says 4.99999. Okay. It just has rounded to 5. It doesn't, the graph would not actually ever hit 5. Okay. I need to know what the right end is doing. It looks to me like the right end is also doing the same thing, right? Getting close to 5 from above. But I'm going to go back over here and put in, what kind of big numbers would I test here? 1,000, positive this time. What do you think? Is it confirming that it's approaching 5? Okay. Okay. Now, if you wanted your calculator to generate points, I don't think you need to do this right now, but you would want it, if you wanted to go back and use the table like you're used to, guys, you would want to go back to auto, and then it would just give you all kinds of values.
We just go to second window, right? So we'll go to
Yep.
table set.
Yep. All right, back to the question. Why won't, okay, well, let me even move this. Ah, there we go, go away. So, how do we write that this is approaching 5?
As negative x approaches negative infinity, f of x approaches.
As x approaches the far right of the graph, it is also approaching 5. What I want you to understand is that you're not always going to be able to tell from the equation what it's approaching. You're going to have to look at the graph. You might have to use some of these tests to find it. A lot of times the graph is going to be either going up or down, right? Infinity, negative infinity. But once in a while you're going to have something else. All right, can you tell me this one? I don't even care if we don't write it down. Somebody tell me.
As the x approaches negative infinity, f of x approaches infinity.
Jared, you okay with that? You'd have x is going to the left. I would write what? I'm going to cheat and not write f of x. I'm going to write y is going.
That face.
Both ends are up, Jared, so they would both be positive infinities for the y. Is that okay? All right, back to continuous, discontinuous, guys. Can you tell me this? What's going on at negative 4?
There's a hole.
There is a hole, so is this continuous at negative 4?
Absolutely not.
That's all you got to answer for me. Number 7.
Yeah.
Can I put in a 1?
Yeah.
Is a cubic graph have any, plain old cubic graph have any holes anywhere?
No.
So it's continuous. All right, what about this one? It asks 2 different places, negative 1 and or 2. What's going on?
Well, we would have to know that it equals 0. Find out.
If I were requiring you to find the different kinds of discontinuity, this has 2 different kinds, but I'm not requiring you to know that. If I put in a negative 1, I actually get 0 over 0. Okay? But is that possible?
No.
So it's discontinuous. So is it continuous? No. That's a different kind of discontinuity than if I put in a negative 2. If I put in a negative 2, I get negative 1 over 0, which is still a no, but it's a different kind, okay? Actually, it has a hole at negative 1, and it has asymptote at -2. So this would be a removable discontinuity, and this, what? You can if you want. It has an asymptote at -2, which is an infinite discontinuity. But I'm just going to ask, is it continuous? Yes or no? All right, number 9.
Yeah.
Shh. Guys, can you type number 9 in real quick? I just want to practice. I know there's some of you, ladies in the back, who don't have a ton of experience with the graphing calculators. There are also some of you who had Algebra 2 with teachers who did not utilize them a great deal. X to the third plus 5x squared minus 4. Okay? It says in the question that we are interested in finding zeros between -6 and +2. So I actually set my x min to -6 and my max to 2. But you don't have to. You could leave it -10 to 10 and it wouldn't matter. Okay, my x's, it says here, I'm looking between -6 and 2. It just made the graph a little easier to look at. This is really not a great window because it goes off the top, but I'm only interested in the zeros. The directions say between what numbers, between what two consecutive integers do you think there's a zero? But I think -5 and -4, consecutive integers means just one number apart. Can you tell where this one is? Between -1 and 0, you're thinking, and over here, 0 and 1, okay? That's an estimate, all of that. That's useless to most of us because we're just going to turn around and find them, okay? I'm not even going to ask you to do that part. You don't have to find the consecutive integers. When the directions say find the consecutive integers, I don't care. Just find the zeros. And I didn't assign 10 of them, okay? But I want you to find the zeros. So show me that you can find the zeros. Now, if you've done the consecutive integer thing, you can use those as your left and right bounds, right? So second trace, choice 0, choice 2, which is the word 0, okay? And then I know there's one between -5 and -4, so I'm going to put those in as my left and right bound. Hit enter. And it says to the nearest what in the directions? Thousandth. So 4.8, what's thousandth? Yes, 3 places. 828. Now, I think you will struggle with the second one. If you put between -1 and 0, it may actually find it. But yeah, it's actually at -1, I think. I put between -2 and 0 as my bounds because I couldn't tell which side, or not. It actually is right at -1, yes? Mine is having a hard time thinking about that. And the third one, did anybody find the third one? 0.828. Everybody okay? Need me to find it? I'm choosing 0, and there's one over here somewhere. If you were scrolling, you would just scroll over here and make sure you're to the left and then to the right. Miranda?
When we take like ACT or SAT or ACT, and it says to the nearest thousandth, and if it was like a free response thing, would they want us to put -1.000, or would they still take it?
If you put -1, it would be fine. Okay? It is not about significant figures, so you would be fine. 0.828. Everybody okay? All right, guys. I'm going to skip this one. We're good at finding zeros on the calculator. Everybody's comfortable with that. I need you to think. This is like what we call a DOK 3 or 4, a depth of knowledge. You have to be thinking about something here. This formula calculates resistance. This says if the voltage remains constant, if this number up here is a constant number, but the current increases, this number down here is approaching infinity, what will happen to the resistance? It will decrease and eventually approach 0. Does that make sense? Everybody was really quick to answer that. As the number, whatever the number is on top, even if the number is 1,000,000, if the bottom number is getting bigger and bigger and bigger and bigger and bigger at what you're dividing by, that means the whole value will get smaller and smaller and approach 0. You guys are geniuses. You just understood limits completely. Okay? This is a question. I'm going to point this out. If you typed this in, you would want parentheses here and here and here and here. You would not need them around the whole thing, but don't miss this +2. This graph is one you would want to find the left and right behavior by checking on your graph. It does approach, I believe, 7 on both ends, okay? I don't want you to, guys, I don't want you to miss this last question. This is your ticket out the door. See if you can look closely at these and tell me which one is listing the end behavior correctly. Both ends are doing what? Up. So I need
Only one that can work.
infinity, infinity. Okay, as x is approaching negative infinity, it's up. As x is approaching infinity, it's up. So even though I didn't really teach you limit notation, you could pick out of those choices, yes? All right, guys. This is your homework this weekend. Okay, it is listed on the gold sheet. It is the assignment on 1.3. Quiz next week.